All right, so we're going to do a confidence interval and hypothesis test using the central limit theorem. And to do that, I'm going to use some data that one of the authors of our textbook collected from a town in northern New York. They went and looked through marriage records and recorded the age of the husband based on the marriage record and the age of the wife. And then what we want to do is look at the difference, husband minus wife, and wonder, because there's this thing that, this belief that when men are looking for a mate, they tend to look for younger women, and when females are looking for a mate, depending on their age, they're either looking for someone a little older or someone around the same age. And if that were true, then we would expect the difference to be greater than 0, that the husband is on average older than the wife. Now, personally, my wife's a year older than me. One of my best friends, his wife is 15 years older than him. But then I got another good friend who's 15 years older than his wife. There's a lot of variation out there. So I made a distribution of their data here. And you can see on the low end, we have wives that were around 7 years older than the husband, because I have husband minus wife. Positive value, I have some husbands that were around 17, 18 years older than their wife. And then the middle is somewhere in here, which looks to be a little above 0. The middle seems to be greater than 0 here on my histogram. I took a sample of 50 of those 105. And so we're going to take a look at this one. So I'm going to share out this spreadsheet with you. And we're going to run a hypothesis test and a confidence interval on it. So let's copy. Got it. And anyone can view it. And share. So this is husband minus wife data. And there's a homework problem that's very similar to this, right? Take a sample of 30 from this. Play with it in the homework. Okay, so there's this spreadsheet here. And what we're going to do is we're just going to, let's see, do we want to work directly in this sheet? I think I want to put this in that other sheet so we have a whole bunch of stuff in the same spot. So you can either make a copy of this and keep it, or I'm going to put it in with that other, so I have all my different kinds of tests in one sheet. Okay, so I'm going to come back over to this one, and I need to add a new tab. Paste the data in, and we need to give it a name. The tab go. I guess I'll deal with that later. Okay, so the stuff to do with this. So we have this confidence interval for a mean sheet here that we can reuse. We have this hypothesis test for a mean here that we can reuse. Oh, chat, hang on a sec. Yeah, so Tammy has a similar experience. There's a lot of variation, husbands and wives, older, younger. All right, so I think what I'm going to do over here is I'm going to go to first that confidence interval, and I'm just going to copy this stuff here and paste it into my new sheet. That. Where is my new sheet? Did it end up being at the beginning? Oh, there it is, sheet 5. Okay. And to put it down here, put a note here that first I'm doing a confidence interval. Okay, so to modify this, whereas before I just typed in numbers I was given, in this case I'm going to have to calculate them based on the data. So anytime you're given data, don't manually type the sample size, use the spreadsheet to count it. So that would be equals count. And then everything in A is just the name and then the numbers, so I can choose just the whole column. And it says, yep, there's 50 numbers there. X bar, that's mean, average. And then I can just grab that whole column A. And standard deviation of the sample, that would be std.s. Sample standard deviation. Grab the column of data or the individual numbers. All right, and then here, I think I'm going to go for the standard 95% confidence interval. Now, otherwise, my spreadsheet's pretty much ready to go, right? I already wrote the formula from last time. I just copied it over that says to get the standard error, take the sample standard deviation, divide by the sample size. Cool. From the confidence level, to get alpha, I just subtract. To get the tail probability, I just divide by 2. And then to get the t-score, I'd use the t-inverse. So I'm going to double check that with stat key right now. So I have a t-score of 2.00, let's see, if I go out to 4 decimal places, 2.0096. In stat key, anytime you use the t-distribution, if I reset, it's going to ask me, oh, it didn't ask for degrees of freedom. Oh, I happen to have it. If you go to it fresh, it's going to say, hey, what's your degrees of freedom? So that would be 49, sample size -1. And then my t-score, let's see, 2 point, that's a right tail in this case. Oh, wait a minute. Yeah, I can do this. Oh, it's almost got my t-score there. 2.0096. Why am I doing this? I don't know. Yeah, so there's my 2.5% in the tail. So stat key agrees. Otherwise, I can go up here and type 0.025 in the tail, and stat key comes back with a rounded version of that number to 3 decimal places. All right. Then from there, I just get the lower, which is already pre-done because we did this in the previous two examples back. Take your mean, that's your center, and then subtract the t-score times the standard error. And now that I think about this, I think it makes more sense in the spreadsheet to get the margin of error first and then add and subtract it. So let's redo that just for fun. Remind you how to do it. So margin of error for a mean is whatever your t-score is times whatever your standard error is. And we started using that formula last week. Now we know how to calculate standard error in a different way. And then based on that, I can get the lower and the upper. Lower is always the sample. So on average, in this sample, the husband was about 1.34 years older than the wife. We have a margin of error on that, minus 1.29 years, and plus that same thing from the mean. I have to redo this? No, I'm just reminding you where it comes from. Okay, so what we think is we are 95% confident that on average, the husband is about 0.05 years older up to 2.6 years older than the wife. Let's write that down. So we have age difference, husband minus wife. We have a sample of size 50 with a sample mean of about 1.34 and a sample standard deviation, I didn't note that, of about 2 decimal places, 4.55. And then from that, we use the idea of taking our sample statistic plus or minus our margin of error, which in this case is a t-score times the standard error. So that would be our 1.34 plus or minus the magic t-score we got, which was about 2.010, and that was based on a confidence level of 95%. Times our standard error, which I don't recall. That's that 0.643, and I'm going to write down where it came from. The sample standard deviation over the square root of the sample size. And based on that, we found a 95% confidence interval where we have our 1.34 in the middle, 0.04 years on the edge, and what was the other 2.63. I guess that's 0.05, 2.63. These numbers are in years down here. Our margin of error was about 1.29 years. So that's what we discovered. Now, the interesting thing, if I ask the question, is the husband on average older than the wife? Well, a difference of 0 is over here. So this would be, they're the same age, no difference. Is no difference in my interval? The answer, it's not in there. So I think there is a significant difference between the age of the husband and the wife. Even more than that, the husband seems to be older on average. Okay. To test that further, we need a hypothesis test.